Saxon Algebra 1, Lesson 23. Greetings. Today's lesson is going to give you some satisfaction because you're going to listen to it and you're going to say, yeah, I knew all that. That's obvious. And you're going to feel real smart. So let me show you. We'll dive into the first example. By the way, this title, Additive Property of Equality, don't let that scare you. That sounds way harder than what this actually is. Let's take a very friendly looking little equation. Notice it's an equation because it has an equal sign. And we see there's the x, and we know that whenever we have an equation with a letter in it, our goal is to solve by putting this on one side and shoving all the numbers to the other side. Okay, so we'll do that, and we see there's this -3 hanging out, and we go, okay, well, we'll just add 3 to both sides. We draw the line. The format is very intentional and precise, right? We always do it this certain way. This helps us see that our equation is still in balance because we added it twice. Make sure you use the exact format, not only for these problems, but anytime I lay out a problem, use that format because I've considered a lot of different formats and I find whatever I'm using is the easiest to understand and it gets the job done. So trust me on that I have experimented and this is what I'm recommending. Okay, so these two cancel each other out. We just have an x there. And we say that x equals 15. Now, this process wouldn't be possible without this rule, this additive property of equation. And the additive property of equality says, if A equals B, then A plus C equals B plus C. We're saying you can add, as long as you add the same thing to both sides, you'll be in balance and everything will be fine. That's the additive property of equality. And as you see, that's exactly what we did here. We said that this is equal to this, and then we added something to both sides, and that sum is also equal. So we used this as we solved this. You've been doing that for a long time. You know how to do that. It's hardly exciting, groundbreaking news, but we gave it a fancy name. The other fancy name we're going to toss into this is, you know how we have two different equations here? One before we added 3 and then one after we added 3. There's a name for that too. Those are called equivalent equations. Because while they don't look the same, they have the same value. And we can easily toggle back and forth between them. And we run into equivalent equations all the time. You have in the past. So again, fancy names for something you already know. Now here we added 3. We can also subtract a number, right? Because now that we know about the ladder and the meadow, we know that subtracting is just adding negative numbers. So we can use this same rule and put a negative number in here. We can also, as the next fraction will show us, or the next, spoilers, as the next example will show us, we can use fractions. And that doesn't make it harder, it just makes it a little messier. So 23.2, and let me just tell you, we have 3 examples in this lesson. Here's this equation, x plus 1/4 equals -3/8. Okay, we are not going to let the fractions mess us up. We're just going to see, okay, we're adding something to x. We see it's an equation. We want the x by itself, so we will subtract the 1/4. Okay? That's how I know what to do. I look at the x and see, okay, what's happening to x and how can I make that go away? I do it to both sides. This cancels. X equals. Now I just have to subtract, right? Just have to put those two together. The problem though is that we need matching denominators. So we can just multiply this 4 by 2 and that will give us -2/8. And then we combine those. They're both negatives, so we're down at the -3/8 step on the ladder, and we go down 2/8 more. Negative 5/8 is our final answer. Yay! And our last one. This one says k plus 2 1/3 equals 2/9. Now you know how I feel about mixed numbers. I don't even have to say it. I wrote it down. If I was doing the homework, if I were you, I wouldn't even write that down. I would just immediately translate it to an improper fraction. 3 times 2 is 6, plus 1 more is 7, and we keep the denominator the same. And now I want to subtract 7/3 because I want my k by itself. Don't let the different letters throw you. Remember that a letter is just a letter. It doesn't matter which letter it is. X is common, but we can use whatever we want. And that goes for uppercase too. Every once in a while, John throws an uppercase letter in. This is supposed to be lowercase. Mine looks kind of uppercase. Uppercase, lowercase, it doesn't matter. That's just all stylistic. Okay, we're subtracting 7/3 from both sides. K equals, that all cancels. This we have to adjust. 9 and 3, our LCM is 9. And up here, I should just say our LCM equals 8. LCM equals 9, so we have to fix this one. And we get minus 21/9. Okay, and then we're combining positive 2 and negative 21. Remember, in adding and subtracting with decimals, once we get the denominators to match, we can ignore them. And we just pay attention to the neumies. 2 minus 21 is negative 19/9. And that is our final answer. Yay, team. We did it. Okay, so fractions just make it a little more complicated, but they don't change the additive property of equations. Or of equality, however you want to say it. And that's just a fancy name for what we have been doing all along. Okay, lesson 23 is over. Yay, goodbye.